Hello everyone. Under structure and bonding topic, I'm going to discuss valence bond theory, hybridization and types of hybridization. We know that chemical bond means it's an attractive force which holds various constituents like atoms, ions or a molecules together in different chemical species is a chemical bond. And what is the cause for the formation of chemical bond? There are two reasons. The first one is octet structure. Octet structure means the atom of various elements gain the octet structure of nearest noble gas, means in its orbital they contain 8 electrons. And there is an exception, that is helium. It contains only 1s2 electrons, but in rest of the noble gases they having ns2 np6 configuration. And the second reason is minimum energy. When two atoms are combined, they produce as the molecule. The formation of molecule takes place through by losing of energy, and the formed molecule become more stable. Tendency of atoms to form more stable molecule by losing energy, and this favors the chemical bond. In chemical bond there are different types. It may be ionic bond, covalent bond, coordinate bond, hydrogen bond, van der Waals forces and metallic bond. Here I am going to discuss only the related topic on covalent bond. To explain the formation of covalent bond, there are two theories are established. The first one is valence bond theory and the second one is molecular orbital theory. Valence bond theory. Valence bond theory, which describe the formation of covalent bond as well as electronic structure based on overlapping of orbitals and pairing of electrons with opposite spin. This theory was first introduced by Hitler and London in 1927. Valence bond theory having some postulates or characteristics. A covalent bond is formed by overlapping of orbital having two unpaired electron with opposite spin. Overlapping means when two orbitals share a common region in a space. For example, when 1s orbital overlap with another 1s orbitals and forms the SS overlapping, and this is the common region where both orbitals sharing their electrons. The second postulate is when the overlapping between the orbital is greater, the covalent bond formed is stronger. The overlap is directly proportional to the extent of bond formation or strength of the bond. The extent of overlapping of orbital follow the following order. PP overlapping is greater than SP overlapping, which is greater than SS overlapping. Here SS overlapping is minimum because the s orbitals are spherical in shape. When s orbitals are spherical, their diffusion will be very less. Because of this, they provide the less area and the overlapping become very minimum. And the important thing is the overlapping between the orbital is always less than 50%. Next point, overlapping along the axis is more stronger than the overlapping along the sideways. Overlapping along the axis. Along the axis means head-on overlapping. they always produce us the sigma bond, and sideways overlapping or lateral overlapping, they produce us the pi bonds. Next point, the overlapping orbitals should not differ very much in their energies. It's an example of hydrogen molecule. Hydrogen electronic configuration is 1s1. When 1s orbital overlap with another atom of hydrogen, they forms ss overlapping of hydrogen molecule, and it having the electronic configuration of helium. The second example is fluorine molecule. In fluorine molecule, it contains one unpaired electron in p orbital. When these p orbital undergo overlapping, they produce as the pp overlapping. Limitation of valence bond theory. Valence bond theory fails to explain tetravalency of carbon. It fails to explain coordinate covalent bond formation, and also it fails to explain the structure and shape of all the molecules, and also it unable to explain the color of complexes. There is no explanation for paramagnetic nature of oxygen molecule. These are the limitations or demerits of valence bond theory. Next concept, hybridization. Hybridization is introduced by Linus Pauling and Slater in 1931. It explained the nature of covalent bonds in a molecule. We know that atomic orbitals are spherical, double dumbbell in shape, and their energies are different. Whenever these atomic orbitals are mixed, they form the new atomic orbital which having equal energy, and the formed new orbital is termed as hybrid orbital, and the phenomena is termed as hybridization. It is the process of intermixing of two or more atomic orbitals of valence shell of an atom to form same number of identical orbitals of same or nearly same energy. Such formed new orbitals called as hybrid orbital. The hybridization is a hypothetical concept, and it is only concept for sigma bond and lone pair of electrons, and there is no involvement of pi bond. It having some characteristic and the postulates, that is, the number of hybrid orbital formed is the same as number of hybridizing orbitals. The hybrid orbitals are all identical in shape and energy. The number of electrons after hybridization in the hybrid orbitals remains the same. For example, when 1s orbital intermixed with 1p orbital, it will form 2 sp hybrid orbitals which having identical in shape and energy. 1s orbital, 3p orbital and 1d orbitals are intermixed. It will form 5 sp3d hybrid orbitals. The number of intermixing orbital is equal to number of hybrid orbital formed. They are identical in shape and energy, and there is no involvement of electrons. Hybrid orbital continues to be an atomic orbital associated with a single nucleus. Pauli's exclusion principle and Hund's rule of maximum multiplicity are obeyed. According to the Pauli's exclusion principle, an orbital can accommodate only two electrons with opposite spin. According to the Hund's rule, in an orbital, pairing of electron will take place after they filled with single electron. The hybrid orbital are directional in space to have minimum repulsion between electron pair, and thus stable arrangement will take place. Hybrid orbitals are oriented in that direction. The repulsion between them should be minimum and give the particular geometry. The both half-filled, fully filled and empty orbitals can participate in hybridization. Fully filled means lone pair of electron also participate in hybridization. Empty orbitals we can see in coordination compounds. This is about postulates of hybridization. Condition for hybridization: the orbitals belonging to the same atom only can participate in hybridization. Orbitals undergoing hybridization should have almost equal energy. For example, 2s and 2p orbital in carbon, or you can take 3s, 3p, 3d orbitals of sulfur. Energy of the orbital can be calculated using n plus L rule. The promotion of electron is not essential condition to undergo hybridization. Only orbitals are undergoing hybridization but not electrons. The next point is the hybridizing orbitals may or may not contain electrons. The empty orbitals or fully filled orbital or half filled orbital can participate in hybridization.